Alright, so in this video I'm going to be talking about sine, cosine, and tangent for people who are probably just seeing them for the first time with right triangles and not really understanding them. I'm going to do this video in a pretty unorthodox way. Instead of explaining the abstract to you and then giving you problems, I'm going to do problems myself without explaining the process, and then I'm going to explain what's going on. And the reason why I'm doing this is because I feel like a lot of students tend to feel like math is a lot of information overload. And so I want to do the opposite. I want to give you as little information as possible so your brain can piece together the patterns. That way, when I finally break down what's going on, you can think, oh, instead of, okay, I'll I'll try to remember that, I guess, right? I want you to have a different type of experience here. So if you find this video hard to watch, try to finish it through and then watch it through a second time, because the second time is really it's really going to shine because you'll have seen everything at least one time. So let's get started. As I said, when you start seeing sine, cosine, and tangent for the first time, you're going to be using right triangles. So what is a right triangle? A right triangle is any triangle with an L shape in it somewhere. So for example, in this triangle, or maybe in this triangle, or I don't know, this triangle. Right? There's an L shape somewhere. So here we've got one right here. We've got one right here. And we've got one right here. Although this one isn't the best. What I'm trying to say is that these triangles all include a right angle. A right angle is just a 90-degree angle, and it takes the shape of an L, like this. This is a 90-degree angle. And on your paper, your worksheets, it'll always be written with this little box corner. So this is your right angle. And as soon as you have deduced where your right angle is in your triangle, the first thing I want you to do is draw an arrow out from it. And I want you to stop that arrow when you hit another side of the triangle. And I'm going to do it on both ones. And this side that you stop at is called the hypotenuse. This side is the longest side of the triangle, and you know this side as the letter C in the equation a squared plus b squared equals c squared. That is the Pythagorean theorem. Specifically, if you have a right triangle whose sides are a, b, and the hypotenuse c, then the square of the hypotenuse is equal to the sum of the squares of the other two numbers. So don't worry about a squared plus b squared equals c squared unless you need to find out like lengths of sides. But like I said, the first thing I always want you to do when you have a right triangle is draw an arrow out from your box angle, from your box corner, and stop at the next side. And this side is your hypotenuse. That is the most important thing moving forward. So here I've got two problems from Khan Academy and another problem that I just found on the internet. And I'm going to go through this first problem, giving you practically as little information as possible. I'm going to tell you where I'm getting the numbers from, but not why I'm choosing those numbers. And I'm going to complete this work for the entire triangle. And then for this one, I'm going to let you a little bit more in on what's going on. And then for here, we're actually going to solve a problem. And then from there, it'll just be more of an explainer type video. So this part is going to be the hardest part of the video. It's going to be the most boring and most confusing part, but just stick with me. So our job here is to calculate sine, cosine, and tangent. And when we calculate these, we actually pretty much ignore the right angle. However, I told you, whenever you have a right angle, draw your arrow. So we have our box corner right here, our little corner. So we're going to draw the arrow out, and it hits the side labeled 10, which means that this is our hypotenuse. So it is important that we know that and that we keep this in mind. So for this first problem, I will have this annotated. That way, it's very obvious that this side is important. All right. So in order to do sine, cosine, and tangent, I have to choose an angle, but I'm going to ignore the right angle. So that means my two options are this 20-degree angle and this 70-degree angle. I'm going to choose the 20-degree angle because why not? So I have to write that in because it's the angle I've chosen, and I'll paste those onto both of the other ones. All right, now the next thing to know is that sine, cosine, and tangent are all actually fractions. So I'm going to draw a fraction bar to begin, and now I'm ready to start. Since I've chosen the 20-degree angle, I'm going to start on this side of the triangle. So what I'm going to do to begin is I'm going to do sine. I'm going to calculate sine. The first step to calculate sine is to come to my angle, 20 degrees, and draw an arrow out from it. This arrow stops at the side labeled 3.4, so that's going to go on the top of my fraction. I'm going to get rid of this arrow now because it's kind of cluttering things up. And then what goes on the bottom of the fraction? The hypotenuse. Again, I'm telling you where these numbers come from, but I'm not telling you why I'm choosing them. Now cosine, instead of choosing this side, I'm actually going to choose the one side we haven't looked at so far, 9.4. And then on the bottom, I'm going to put the hypotenuse again. And then tangent, what I'm going to do is I'm going to draw my arrow again. It comes to 3.4. I'm going to put that one on the top. And then on the bottom, I'm going to put that 9.4 again. All right, and that's as simple as it is. Again, you don't know why I'm doing this, so it doesn't make sense, but just stick with me. Now, I'm going to calculate sine, cosine, and tangent, but for the other angle, 70 degrees. All right, so we're going to get rid of all these guys. I don't want to delete the n. And there we go. And now I'm just going to choose 70 degrees. So I'm going to put that here. And again, it's just going to be a fraction. So I'll just copy paste all this stuff here. All right. I'm also going to remove my work for the 20 degree. So now I'm going to do the same thing. I'm going to solve sine. So the first thing I'm going to do is I'm going to go to my angle and I'm going to draw the arrow out. It points to 9.4, the side labeled 9.4. So I'm going to put that on the top of my fraction. And on the bottom, I'm going to put my hypotenuse. All right. I'm going to get rid of this arrow because I don't want it there. Now for cosine, again, so for sine, I drew my arrow and I went to 9.4, and then I used the hypotenuse. Just like this one, we're going to look at that third number we haven't mentioned, 3.4, and on the bottom, I'm going to do the hypotenuse. And then for tangent, I'm going to draw my arrow again. It points to 9.4. And then on the bottom, I'm going to put that third number again, 3.4. Sorry. All right. So that's going to be that. Now on to the next triangle. And actually, before we move on, I want you to pause the screen for a little bit, and I want you to compare these values over here with these values. All right, on to the next one. So now I'm going to calculate sine, cosine, and tangent. The first thing to do is to find our right angle, draw the arrow out from it. It stops at the side labeled 10, so 10 is our hypotenuse. So the way to calculate sine is we first choose an angle. I'm going to choose 50 degrees. And it's just a fraction, so I write my fraction bar. So how do you calculate sine? Sine goes by this formula, opposite over hypotenuse. Opposite over hypotenuse. So the first thing I do is I ask, what is the opposite? By the opposite, I mean the side opposite to your angle. So you find your angle, you draw your arrow, and it points to the opposite side. That side length is the opposite. It goes on the top of your fraction. And the hypotenuse is on the bottom. The hypotenuse is 10, as we see from here. All right, so how do you calculate cosine? Cosine is adjacent over hypotenuse. All right, so what's the adjacent? Well, process of elimination, right? The opposite side, we drew the arrow to, is 7.7, the hypotenuse is 10, so the adjacent side has to be 6.4. So that's why I said like that one number that we weren't doing anymore, blah, 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 that we weren't talking about. That's going to be this guy. This is the adjacent side. And then the hypotenuse on the bottom is 10 again. Hopefully you can start to see a pattern now. When we did 20, we drew the arrow, 3.4 went on top, then 10, then 9.4, then 10. It's the same thing going on here. And then finally, tangent is opposite over adjacent. And we've already got the opposite and adjacent. We just have to go back to the sine formula. It's at the top, 7.7. And the adjacent is that other number, the 6.4. All right. And if you didn't want to do that, the other way to do it is just to make sure you've got your line. The line points to the opposite, so 7.7 goes on the top, and then you need the adjacent side. Well, 10 is the hypotenuse because it's the opposite of the right angle, so it's got to be the 6.4, and that's how you do that. So now that we actually know where these numbers are coming from, let's do it again, but let's do it from 40 degrees. So I'm going to copy everything over from this side, and I'm going to delete all these fractions, all the 50, 50, 50, and it's just going to be 40. Right? So we did this angle, now we're going to do this angle. 40 degrees, 40 degrees, 40 degrees. And it's just a fraction, fraction, fraction. So now what do we do? For sine, opposite over hypotenuse, right? Op, hype. And then for cosine, it's adjacent over hypotenuse. And then for tangent, it's opposite over adjacent. Not very organized, but who cares? I don't want you to remember like opposite, adjacent, blah blah blah. I want you to remember the process. So I mean, I'll definitely give you a way to keep this in mind in the future, but let's just keep going. So sine, the first thing I'm going to do is I'm going to draw an arrow out from my angle. It points to the side labeled 6.4, so that's going to go on top. What goes on the bottom? The hypotenuse, 10. Now, for the cosine, we don't use the opposite, we don't use the hypotenuse, but we use the adjacent side on the top, 7.7, and then on the bottom we have the hypotenuse. And then for the tangent, we have our arrow pointing to the 6.4, so that goes on the top, and then on the bottom we use the adjacent side, 7.7. And here's what I wanted you to notice on the last one. I'm going to color the 50-degree angle blue, and I'm going to color the 48-degree angle green. What I want you to notice is that when you switch, first we studied the 50-degree angle, and then we studied the 40-degree angle. So first we studied blue, then we studied green. When we studied blue, we got 7.7 over 10, 6.4 over 10. When we studied green, we got 6.4 over 10, 7.4 over 10, 7.7 over 10. So that is the sine of the blue corresponds with the cosine of the green. The cosine of the blue corresponds with the sine of the green. If that makes no sense, just look at it. Just pause the video and make sense of it. These tangents, these are related by reciprocal. So that is, if you flip this fraction upside down, you get to this one. So that's all that's been going on. This is all sine, cosine, and tangent is. You draw arrows, and you make sure you've got the right sides labeled. So now I want to do one small problem with this stuff, and then let's go on and let's have a more abstract explanation of everything that's going on. So we want to find the value of this side x, and we don't have this side here, so we can't use a squared plus b squared equals c squared. I was going to write another plus. We can't do that because we're missing a side. We only have two sides, and it's not the hypotenuse that we're missing. It's this side here. There's absolutely nothing, just not even a variable. So how do we do that? Well, we've got an angle here, so maybe we can try something with sine, cosine, or tangent. Typically, you say sine, cosine, tangent, So if you say sine first, why not try sine first? So in order to do sine, you have to pick an angle. You ignore the right angle, but you make sure you know your hypotenuse. So we ignore this. We don't have a value here, so there's no point. But we have a value right here. So sine of 75 degrees. It's a fraction, so you just have equals fraction. So how do we do sine? Opposite over hypotenuse. Or to do sine, draw your draw your arrow. It stops at the sign label 10. So 10 goes on the top, and your hypotenuse goes on the bottom. Where's your hypotenuse? It's the opposite of your 90-degree angle. So this is x. So now, if you need to take your time to do your algebra, you know that you multiply both sides by x. And this gives you x times sine of 75 degrees, which is equal to 10. And then you just divide by sine of 75, which gives you x equals 10 over sine of 75. But if you're a little bit quicker like me, then what you'll do is you'll just flip both sides of the equation. Basically, you pretend that this is sine of 75 divided by 1, and you just flip this fraction, and then you flip this fraction. So you get 1 over sine of 75 equals x over 10. And finally, x equals 10 over sine of 75. All right, so that's the answer. You can just plug that into your calculator, or if you don't even need to do that, you can just write that down, and that's your answer. That is the length of the side x. And it's as simple as that. So that is the worked problem, and now it's time to get into the confusing stuff. All right, so let's see what is going on. I want you to imagine that you've got a line and that this line can spin around like a hand on a clock, except we will be going counterclockwise instead of clockwise. So a right triangle begins with a right angle, so perhaps this one here. Quite uninteresting. I will just make a straight line because I can't be bothered. And one more side. All right, so here is our right angle. Here are our other two angles, and we've got three sides. I will name these angles alpha and beta. I will name this side H, and I will arbitrarily label these sides L1 and L2. And I feel inclined to do the reverse, but I've already made a convention for the video, so I'm going to stick to it. So, sine, cosine, and tangent are just, in the beginning, they're just ratios, but let's do it. So sine of alpha, you just draw the arrow out, and it's opposite over hypotenuse. So you draw the arrow out from alpha, and you pick your angle to do sine. You draw your arrow out. Whatever you point at is your opposite, and then you have your hypotenuse on the top. Cosine of alpha is going to be adjacent over hypotenuse. So you ignore your opposite, you ignore your hypotenuse, and you pick your L2. That's going to go on the top, L2 over hypotenuse. And then for tangent, tangent is going to be opposite over adjacent. So you find your opposite side, L1, and throw it over your adjacent side, L2. Now, I'm going to also add in another level of complexity, which is that tangent of tangent is always actually equal to sine over cosine. In the future, you'll need to know this, at least in your math classes, that sine is equal to cosine. That tangent, is equal to sine over cosine. And how do you know this is true? Well, I mean, I don't want to write a proof, but what you can actually do is you can just forget about this. Like sine of alpha looks scary. We know what sine of alpha is. It's right here. So we can just plug that in. L1 over h. And again, cosine of alpha looks scary, but we know what it is. It's right here. L2 over h. And if you've been doing really good with your algebra knowledge, then you should know how to divide these two fractions. This is what I think they call this a complex fraction, but basically you've got one fraction divided by another fraction. And so you just don't freak out about this, just rewrite it as one fraction divided by another fraction. And how do you do this? Well, change this to multiplication and flip this fraction, get its reciprocal. So that's going to be L1 over h times h over L2. Now, also remember your algebra skills here. When you only have multiplication going on, absolutely no addition, subtraction, you can have it, but in specific cases. When you just have multiplication going on, if you have two things on the opposite side of the fraction, so if you imagine this is just one fraction, so you've got h on the top and h on the bottom, and there's only multiplication going on, you can just cancel them out. They just become 1, and 1 is insignificant. So this just becomes L1 over L2. So in the case of right triangles, this is very easy to demonstrate. This agrees perfectly with what I've got right here. Opposite over adjacent, L1 over L2. So now I just proved that L1 over L2 is the same thing as sine over cosine. All I did was I replaced sine, I did a substitution with the fraction. That's all I did. And now I want us to go over, and let's do this from beta's point of view. So sine of beta is going to be opposite over hypotenuse. So first thing we do is we find the opposite of beta. We draw out our line to get to L2, and our hypotenuse is h. And then we do cosine beta, which is going to be adjacent over hypotenuse, which is going to be, it's going to be, sorry, it's going to be, so it's not going to be our opposite, it's not going to be our hypotenuse, it's going to be that third side. So it's going to be L1 over h, and then tangent is going to be opposite over adjacent. Opposite over adjacent. And that's going to be, your opposite is going to be L2, and your adjacent is going to be L1. And again, we could demonstrate it. I'll leave this to you to demonstrate that tangent of beta. Oh my god. Tangent of beta is equal to sine of beta over cosine of beta. It's effectively the same as what I just done, but it's a decent mental exercise for people who are struggling in this kind of stage. So there you go. But let's bring this all together, right? We've seen that sine of alpha is L1 over h. L1 over h. Sine of alpha is cosine of beta. Cosine of alpha is L2 over h. So that's this guy over here. So this is getting kind of messy, but here's what I want you to know. If you're working on a single triangle, if you've got just one triangle, boom, 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 ignore your hypotenuse, you've got your two angles, you've got alpha, you've got beta. When you study the sines and cosines of these two angles, here is the relationship that you get. You get sine of alpha equals cosine of beta. You get cosine of alpha equals sine of beta. And you get tangent of alpha is equal to 1 over tangent of beta. And that's really all there is to this, at least at a very fundamental level. This is all you need to know to do this. So I guess to end it off, I suppose it would make sense to do this one more time and to also introduce a mnemonic to you. And this mnemonic is so ka toa. So SCT, they stand for sine, cosine, and tangent. O stands for opposite. H stands for hypotenuse. And A stands for adjacent. So let's do it. Let's do sine of 20. Sine of 20 is going to be the opposite. Let's get rid of this garbage here. Let's get rid of it. So sine of 20 is going to be the opposite, 3.4, over the hypotenuse, 10. Cosine of 20 is going to be the adjacent side. It can't be this side, it can't be this side. It has to be 9.4. 9.4 over 10. And tangent has got to be opposite over adjacent, and that's going to be 3.4 over 9.4. And you shouldn't be writing this down. You should keep this in your mind. So ka toa. So ka toa. Now let's do it for 70. Sine of 70. How do I calculate sine? So, sine, opposite, hypotenuse. So what is the opposite of 70? The opposite side, we just draw our arrow out, and you should do this in your head. You shouldn't even do this on your paper. It's 9.4 over 10. Definitely do it on your paper if you feel like you need to. 70. Cosine of 70. So ka, adjacent over hypotenuse. So it's not going to be the opposite. It's not going to be the hypotenuse, but it's going to be 3.4 over 10. And toa. Sorry. You can see how ahead of myself I'm getting. 70. Tangent of 70 is toa. So opposite over adjacent. So the opposite is 9.4 over 3.4. And if you want to make it really fast, then you already know we've already wasted our time. We didn't have to do any of this because we just get this, right? These guys are the exact same. These guys are the exact same. And for these guys, you just flip it. I didn't even have to calculate it. So this is sine, cosine, tangent at a really basic level. I hope I made it easy. Like I said, if you struggled, watch it again. And I've actually realized I've forgotten to explain something, so I'm going to do that one more time. And the thing I don't know how to make this like make sense to other people, but imagine you have an angle like this maybe, or like this, or like this. Your angle is made out of two lines. This line, this line, this line, this line, this line, this line, and the angle comes from these lines meeting at one point. Right? So when you have an angle, you have two lines that create it. And the reason why, like the way you can keep in mind that like this side is the adjacent side, for example, for angle 70, is that when we say adjacent, we mean next to, right? Like if I'm adjacent to you, I'm next to you, right? So the adjacent side, there are actually two adjacent sides. There's here and here, but when we do our trigonometry, right, there's only one adjacent side to care about, right? If you're 20 degrees, your two adjacent sides are your hypotenuse and your other adjacent side. And then you've got your opposite, right? So you don't have to remember that your adjacent side is the one that's not your opposite, the one that's not your hypotenuse. It's the adjacent side that isn't your hypotenuse, right? It's that third side of the triangle that we haven't touched. Anyway, that's all I've got for you. I hope it made sense. Good luck on your stuff, and come to me if you have any more questions. Peace.